Hi, and thank you for watching this video on the RadioLab. In this video, I'd like to give you an overview of what the RadioLab is, what are the individual building blocks, the software ecosystem, what additional modules are available, what you can do with it if you're a beginner, like how, as a beginner, how can you use it for learning, and for more experienced people, how you can use it for rapid prototyping and making your own custom modules. And I'll also go through who it's not for, because this is also very important. So who am I? I'm Louis, also known as EI8KI, and I've been experimenting with radio since I was 13, way back when in 1981. The first radio I built was from a Ladybird book, making a transistor radio. And I've been experimenting building radios and transceivers on and off, depending on what's happening in life over the years since. So what is the RadioLab? Well, in essence, it's an integrated laboratory system with lots of building blocks to allow you to build and experiment with receivers for AM, shortwave, FM broadcast, 2-meter FM, 2-meter SSB, all the ham radio bands, covering anything from AM to CW SSB. You can also build a transceiver with the RF amplifier module, and with this you can build direct conversion receivers, super heterodyne I/O phasing receivers, software defined radio, and universal DSP integrated AM, FM, shortwave, longwave receivers. The software, it's all open source, so you can use it as it is, or you can modify it to your own needs. There's large prototyping areas here, and to allow you to either plug modules in, like these ones, or to create your own modules that you build and work with the rest of the system. So when we look at this, I'll go through the individual building blocks, but what's really important for me is some key components in any radio are top quality. So in this case, our mixers, we use ADE-1 mixers, which are very high quality double balanced mixers and works up to 500 megahertz. There's a low noise RF amplifier that works up to 2 gigahertz. And for the audio, because every radio needs a good audio amplifier and not an LM386, this is a 7-watt audio amplifier, and it produces undistorted warm sound that can fill a room. The key aspects of this is every single RF module or building block has high frequency SMA connectors, so that you can connect them with RF cables, maintaining signal integrity and reducing noise. You can also connect the modules with jumpers, and these jumpers connect modules that are normally connected to each other. It's very common that the IF amplifier will follow the IF filter, so we have a jumper between these. We then have the double balanced IF mixer after the variable gain IF amplifier, and again a jumper can connect these. So in fact, just using the jumpers alone, which is exactly in this setup, you have a full super heterodyne radio that works perfectly. The full schematics are available to you, and all the CAD design for the prototype boards and the part library, and every part is used there, so you can use it to create your own designs. And the greatest advantage for you is that when you're experimenting with a new circuit, you only need to concentrate on the circuit that you're actually working on, and you can put that in there and work with it. There's lots of examples here. So this is an example of a 8-pole audio amplifier, audio filter circuit for CW. Very, very tight filter. So you can basically put this in here. All these prototype boards are available. Develop your circuit, but that's really part you have to develop. You can take the audio out from the double balance. I RF mixer, feed it into that, and then into your audio amplifier. So you can work on each section at a time. So ultimately then, what can you do with this RadioLab? So if you're an experienced constructor or experimenter, you already know the advantages of being able to concentrate on the circuit you're experimenting without having to build a full working system. And when you're working with known good modules or building blocks, and then you just swap your own one in and experiment on that. If you're new to construction or experimentation, that mightn't be as obvious, but you can start off using the proven building blocks and just get a feel for how different types of radios function. My advice for most people is, if you are new, start off with an audio amplifier. Build an LM386 on the breadboard, and then maybe try a discrete transistor amplifier. And the real beauty of what accelerates your learning is you've only to build one circuit. You have a working radio and you just swap the circuit in and out of the one that you want. Building audio filters using op-amps is not only a great way to learn, but it can make a profound difference in the performance of the receiver as well. So, ideally, once you've built up your confidence in audio frequencies, you can start experimenting with RF frequencies. The breadboard isn't ideal for that, but you can start with a board like this and create a diode ring mixer and replace the double balance mixer and just compare them. And you'd be surprised how the performance of a homebrew diode balance mixer can be pretty good. You can then possibly check and look at a transistor version of an RF amplifier. The humble 2N3904 is it's almost a free transistor that will work up to 30 megahertz. You can add additional bands to the RadioLab with replicating the RF bandpass filters. 2 transformers and a couple of capacitors is all that's needed. And you can use the spectrum analyzer function here to tune the RF bandpass filters to match the band that you want. Crystal filters are both art and science. You can build a CW filter that really performs well with 3 or 4 crystals and just a few passives. And again, you can use the built-in spectrum analyzer to match these. So by swapping your crystal filter design with the one provided and compare the performance. Designing oscillators is fun, and there are many types, but you can start off with a crystal controlled one that acts as a BFO for this double balance mixer. And you could then move on to other ones, variable frequency oscillators, and have a full analog setup. Adding AGC to the IF amplifier is another interesting challenge. There's an option on the IF amplifier module to allow external control on the input. So you can start off with audio derived control signal and then do an IF frequency derived control signal. So at this stage, you're starting to really master the art of radio building. You can take individual blocks that you've experimented with and build your first receiver. And this is all your own work. And it's unique to you. And I have to tell you, if you've never done this, the feeling you get from achieving this is priceless. For me, the only better feeling that you get from the hobby is when you build the transmitter side of it and you put out a call and somebody answers. And it makes you feel like you're Marconi, so it does. So just then looking at who this is for and who it's not for. So if you want to learn real RF design, not just assemble kits, you want to understand why radios, how they actually work internally. You want a fast platform for radio experimentation and building, custom receivers, software-defined radios, RF subsystems. You want to kind of just understand, or if you're in some ham radio groups and meetups, people have bought these to teach others electronics and radio engineering. Allows you to prototype quickly without rebuilding entire systems. So, also, you just need to go through who this is not for. So it's not for you if your goal is, I want to finish consumer radio. That's not what this is. At a minimum, if you're new to building radios, you need to be able to solder and really have a keen interest in learning, trying things, and going through the learning process. It's a laboratory, it's not a black box appliance. That said, the sense of this achievement from doing this is fantastic. So that's the RadioLab. You've seen the hardware building blocks, you've seen the software side, and you know who it's for and who it's not for. RadioLab is not a black box, it's not a finished radio. It's a hands-on RF laboratory that lets you, experience, measure, understand, how radios actually work, and then gives you the freedom to modify, extend, and prototype and build your own ideas. And if you've ever wanted to properly understand, super heterodyne, SDR radios, mixers, gain stages, frequency synthesizers, software-defined radio techniques, or just experiment without, needing a bench full of expensive equipment, then that's what the RadioLab was built for. So if it looks like something you'd enjoy working with, head over to radiobuilder.org and get yours. Thanks for watching, and hope to catch you on the RadioLab support group soon.